Hello everyone, this is Jimmy and welcome to episode 17 of Nuclear Earth Reirradiated, where I have a fission reactor. The fission reactor we built last episode has been running for a while and it's been going through our TBU oxide fuel, which leaves us with depleted TBU oxide of 1,500 pieces. I am somewhat curious how much of a percentage of our fuel is that? Let's see. Ugh, like 50% of our TBU and hasn't even touched our uranium yet. I'm thinking because of this, we're going to need actually a separate reactor to run the uranium fuel. Once we get through these steps, like the ratio of how often we have to do TBU and the LEU 235 as well as LEU 233, basically we have to do these three reactions probably more often than everything else combined. So why don't we start off by building two more reactors, one for each of those fuels. So this will be our thorium reactor. I probably stack it vertically. I don't actually know. Can you wall share these reactors? Probably not, because then the controller wouldn't know which one to control, right? Maybe, possibly. I'm not going to try. But yeah, I'll stack another one vertically above it to run lowly enriched 235, and then when we get there, we'll probably stack another one to run lowly enriched 233. But building time, I guess. I've already built out most of the components, so, shouldn't be that. Actually, can I copy paste gadget the entire thing? Let's find out. It looks like it can copy everything except the controller, so, I mean, I'm okay with that, right? And then I want to put it, oh dear. Might need a filler block here. Right here, is it? If I put it here, let's pin it, make sure that's in the right spot. I think that's right. Yeah, that'll do. Do the thing. Woohoo! And it built an entire reactor for me. What a deal. Just need to add a controller. This reactor, when we turn it on, will burn our 235 oxide fuel and produce 60,000 RF a tick. It's actually, like, between the two of them, it's a non-trivial amount of energy. Maybe I shouldn't literally ignore it, but it's running. Now, as we run more of these, if you look in the lower left corner, our radiation value is going up. It's not to the point where it's unsurvivable or anything, but it is a little bit unpleasant. I think I would like to do something about that because, I mean, if we get a little bit away, like, at this point, this is basically, well, one is background radiation. We have to get a little ways away before it decays into background radiation. And it's kind of like, it's not quite the dead center of my base, but it's relatively central in my base. So I like to do something about that. There is an item called the radiation scrubber, which according to the tooltip uses energy to remove radiation from the chunk it's in. Hey, I'm down for that. 25 RF a tick to remove radiation. All right. Let's see. The radiation level will fall linearly at first, but will double. Basically, I think it means that you can't use infinite, or you can't use like a whole bunch of radiation scrubbers to reduce radiation to 0, which is okay. We don't have to reduce it to 0. All right. So the item here is actually pretty simple, with the exception of borax. So borax, ready to dive into a rabbit hole here? Take borax solution, which is sodium fluoride plus boric acid. Sodium fluoride is, I think there's an easier way to make this, made from the sodium fluoride dust, which is made from willemite, which is made from crushing granite. All right. That part could be worse. You can also make sodium fluoride by reacting methylfluorane with sodium. Yeah, let's not say we did. The other half of this, the boric acid, that is diborane plus water, which is from molten boron, plus hydrogen, and I guess any hydrogen. I guess that's it. All we have to do is melt boron. So let's set up a production chain for this. Each radiation scrubber uses 4 borax, and based on the tooltip, I think it only works in one chunk. It will remove a maximum of 20% of the radiation in its chunk. Although, if you have multiple, like, since the reactor spans, actually, does my reactor span multiple chunks? It probably does. Probably just by luck it spans 4 chunks. Oh, look at me. I hit the corner. So we'll probably need to fill those 4 chunks with radiation scrubbers. So we'll probably need a fair number of these borax pieces, so I'll probably make something that is at least mostly passive. As far as inputs go, we'll definitely have to input. Is there a way to make granite? Kind of. You can make it out of diorite, but you use a lot of quartz to do so. There's no igneous extruder in this pack, unfortunately. Here, let's pin actual. Oh, I already have actual granite pinned as a filler block. We get some from the void resource miner. I'll probably just manually input granite, and the other thing we have to input would be... Is that literally the only thing? No, and boron. So yeah, I'll probably just manually input these two things, and everything else will be... Everything else in the process will be automated. The total input to output ratio is 2 pieces of granite plus 2 pieces of boron make 1 piece of this borax, and you get some of the other granite byproducts, which just eventually sit in the ME system. So let's walk through all the steps then. Granite goes in, gets crushed. Everything just gets stored because there's some byproducts here, and it's not so much that I'm worried about it jamming the system. Likewise, boron goes in, gets melted. This process uses hydrogen, but it actually produces more hydrogen than it consumes. So you just have to give it a little bit of hydrogen to get it started, and then you don't have to keep feeding it. React it with hydrogen, because in this next step, you get your hydrogen back. You actually get twice as much hydrogen back as you put in. So, cool. I'm okay with that. Anyway, so that makes boric acid. On this other side, yada, yada, yada. Manufacturing the villamite. Enrich the fluoride. Chemical reactor. It feels very Greg Tech. Finally, you get borax solution, which is 666 to 1. I think that's just like the general convention is that crystal type stuff, like gem type stuff, is 666 millibuckets to 1. I don't know why that's the case, but anyways, that final product gets jammed in the ME interface, and we have a bit of borax. Nice. So let's set up the recipe for the radiation scrubber now. Is that the only thing that uses borax? Sure looks like it. And test it out. So, radiation scrubber. Oh, elite. I don't know how to make elite plating. Oh, shoot. Crystal binder. Oh. Yeah, crystal binder is annoying because it uses... The rhodochrosite comes as a byproduct from crushing the granite, so that's great. Magnesium's easy, but the calcium sulfate's another chemical process. Oh no. And it uses sulfuric... I guess we could use Mekanism sulfuric acid, which is easier to make than Nuclearcraft sulfuric acid, I believe. Crushed fluorite comes from what? Crushing diorite? Alright, well, could be worse. Never mind. There's so many different ways to make sulfuric acid in modded Minecraft, I get them all mixed up. Both the Mekanism and Nuclearcraft sulfuric acid are approximately equivalent, and Nuclearcraft machines are not so strictly sided, so they're probably a bit easier to use. But it requires making sulfur trioxide, which is sulfur dioxide. There's some other thing here. I think this is some weird way to do it. But anyway, sulfur dioxide, which is made from sulfur. Oh, well, there's like 7, there's even more types of sulfur now, and oxygen. And then sulfur is just made from melting sulfur, obviously. All right, well, let's get started. So, an ME interface provides sulfur, and you just put it through a couple of machines that jam oxygen into it a couple times, and then you jam some water into it, and bam, sulfuric acid. Simple as that. All right, now for the other half of the equation is fluorite water. So that's crushing what again? Crushing diorite. As before, I have an input chest to just dump a bunch of diorite into, because my diorite right now, I mean, I guess it technically is passively produced by my void resource miner or whatever, but it's not very fast. Anyways, dump input, crush it, store byproducts, enrich it, chemical reactor it, crystallize it, store final product. And this is calcium sulfate. How exactly do we get calcium sulfate from fluorite and sulfuric acid? Where does the calcium come from? That is what, right? Fluorite? That's fluorine. Sulfuric acid is sulfur. Where does the calcium come from? Does fluorite contain calcium? Huh, turns out it does. fluorite is calcium fluoride, CaFl2. So I guess that's where our calcium comes from. Good to know. Anyways, with that, we should now be able to make scrubbers. Yep, not 10 yet because it just hasn't had enough time to process, but let's make 5. All right, do the thing. I believe radiation is actually entirely chunk-based, and the chunk that contains the controller is what gets assigned all of the radiation from the reactor, and then just decays from there. So the fact that my reactor spans 4 chunks is actually okay, because the controller is 1 block, and it's in this chunk. So anyways, again, because it's chunk-based, I'm thinking we'll build it up high in the air, because we don't have to see our radiation scrubbers working. The balloon from Immersive Engineering is just a... basically, it's an angel block. Let's place a floating block. So let's place 4 of these here and just see how it does. So 4 of those will power them with a quantum thingy to teleport energy up to here. Energy output, all sides. Is that powered? Yeah. And hey, would you look at that? I assume that means that each one is reducing 24 millirads per tick. And they're running at 53 or 60-ish%. I think the efficiency number is the efficiency of that given scrubber. Probably on account of the fact that there are lots of scrubbers around. So if I stack a couple more here, I mean, again, because of diminishing returns, right, there's no reason to put like 50,000 of them. But the radiation we're exposed to is already down to 12 millirads per tick, down from, what was it before, like 28? So we got about half of the radiation scrubbed. So I think if we put another 10-ish here, that should probably render this chunk effectively safe. And then now if I move over a chunk, this was 8 before, right? So I think if we scrub radiation from the chunk that it's coming from, the spread will also be reduced. Let's see about that. And I honestly have no clue how these things determine their efficiency, but they're doing a thing. So you know what? It's good enough. In this area now, our radiation is down to microrads per tick. So effectively gone. And the area around it is down to background radiation. So I think you can't scrub, or at least you can't easily scrub background radiation. But yeah, now our nuclear reactor is not poisoning us anymore, which is very good. Technically, the fusion reactor also produces radiation, but I don't think it's enough that we meaningfully care. So anyways, why are you not running? Oh, because I didn't take the spent fuel out. Whoopsies. I would do it. All right, now you are ready again. So, anyways, now that we've dealt with the immediate radiation problem, let's claim our quest rewards. Claim all. Sure. And then there's some nuclear rewards here to be had. Graphite dust, that's fine. And lastly, Grains of Infinity. Alright, well, useless quest rewards. They were useful earlier, so I suppose I won't complain. Anyways, yeah, now what I want to do is start reprocessing some of our spent fuel. So we have spent 2 types of, what's called depleted fuel. We have depleted TBU and LEU 235. All depleted fuel is reprocessed more or less the same way, so I'll probably just set up a large spent fuel reprocessor. And that is, it goes through a fuel reprocessor where it's 20 seconds per, but that's obviously without upgrades, gets turned into various clumps of other stuff. The reprocessing system is always lossy, so making a fuel, right, takes 81 nuggets of stuff. You never quite get the full 81 out, which is why, because our fuel chain is so long, like it's probably going to take 20 or 30 cycles of input at the beginning to do 1 cycle of output at the end. So anyways, yeah, let's set up a fuel reprocessor. Oh dear, spent fuel, very radioactive. Don't hold it. We're at 3 millirads per tick while not holding it. 2 rads a tick while holding it. Yeah, not pretty. I I think our bar was like empty, right? When like last segment, this stuff is gross. And that's even with some radiation shielding. Although I imagine when stuff is this incredibly radioactive, no amount of radiation shielding is going to make a big difference. Anyways, I'm going to have 2 ME interfaces providing the items for it, because I think we have more than 9 different types of spent fuel. And for now, I'm going to start with 1 fuel reprocessor, although I imagine in the long run, we're going to need significantly more than 1. Actually, no, this is pretty darn quick, isn't it? I think I'm going to also set up our... actually, hold on. Everything that comes out of here is a nugget. So I guess everything should go through a compactor, because they're not very useful in nugget form. We're going to send everything through a compactor, and then into a storage subnet. Oh boy, even worse. Do not even think about touching plutonium-241. 4 rads a tick? That'll, like, kill you instantly. Ugh. Nuclearcraft is scary. Wasn't this literally just like 4 rads a tick? How's it down to 71 millirads? I mean, I'm sure it's still Oh, that might be the whole stack. I see. This is per item is 71 millirads. The stack is 4 rads. Yeah, nasty stuff. Anyways, with this though, all of our fuel will gradually get reprocessed. It gets reprocessed way faster than it gets produced. So 1 reprocessor is plenty fast. Then we just have to now recombine it in various ways to make the next tiers of fuel. So 233 plus 238 make this LEU 233 oxide. I believe that's how you make it anyways. Yeah. Just to prepare for the future, I set up a crafter tower here. These are all Ender Isle crafters that are trying to make whatever, you know, they'll each be assigned a type of fuel. Their inputs will be provided via the interface. They smart pull from it, and then they push the final product into it as well. So anyways, that makes the LEU 233 fuel. We don't make this particularly fast, but I think I'm still going to give it its own reactor, because these cryolattices are pretty cheap, all things considered. So I guess we're building our second reactor for the day. This third reactor then gets fed with this fuel, and then turn it on. It makes 75,000 RF a tick. So technically the 3 of my 3 fission reactors make more energy than my fusion reactor. Alright, given that they make this much energy, let's like stop throwing it away, I guess. What tier conduit do I need to actually move this much energy? I assume, yeah, we've exceeded the capabilities of Ender. We need at least crystalline pink slime. But I guess we can make melodic more easily. So let's make some melodic energy conduits. And I'll probably set up a quantum entanglement port or whatever. Actually, what is the energy throughput limit of one of these? Does it say? For sake of simplicity, instead, I'll just directly plug the energy output to the output side of our energy network. Basically, the energy won't go through the battery, but the battery's full anyways, so it doesn't make a meaningful difference until we, like, upgrade the battery or something. But, yeah, now we have another, well, while all 3 are running, we have a lot more energy. This reactor technically will not run at 100% uptime because, well, in the long run, probably none of them will run at 100% uptime, but because our LEU 233 fuel it takes multiple cycles of PBU oxide to make 1 piece of that, and they run for about the same amount of time. Anyways, now that we've run some LEU 233 though, we have this, which is quite heavily radioactive, so let's try to hold it as little as possible. There actually is an update to Applied Energy 6, to Trousers Applied Energy 6 specifically, that supports ghost items. I just haven't actually applied the update yet, so I have to very briefly... Alright, let's see how bad it is. No, it's not that bad. I mean, it's like almost 1 rad. Oh, is it this interface? Wait. No, it's not that interface. It goes into this interface. Anyways, yeah, there's an update that lets you do ghost items, so if when we deal with the super radioactive stuff that I will not touch with a 10-foot pole, that'll help. I suppose at that point, that's a quality of life upgrade that does have gameplay implications, though. But anyways, that's more stuff being centrifuged, and we now have the next step, which... What is the next step? Highly enriched plutonium-241, I guess? We have 241, and I assume that's made with 241 and 242. Yep, so those are the stuff. Let's set up a crafter to make it. Yes, that's you. You're up. I do have to touch this ugly stuff now. Maybe it's time to apply the update. Alright, let's update so I don't have to touch plutonium. I'm down for that. One quick game restart later. Spoiler, wasn't quick at all. It took like 10 minutes. But I think it was worth it. So there's, we can now drag ghost items from JEI into the ME interface. Like, what an idea! This was a feature in Applied Energistics on 1.7. I don't know why it didn't ever make it into the official branch of Applied Energistics on 112. There is a work in progress. Well, I think the code's already in the repository. It just hasn't been compiled yet. But it'll let you drag out of your bookmarks as well. For now, though, we can't do that yet. So I have to find... What am I looking for specifically? 241 and 242 oxides. 241 oxide and 242 oxide. Now, how do can I increase its count? Yes, we can. Shift mouse wheel. All right. There we go. So that brings that stuff in. And this also works in ghost items. In fact, this also works with JEI import. Unfortunately, the JEI import, does it grab exactly what we're looking at the moment? No. That also doesn't work with the bookmarks. Grumble, grumble. Alright, well, we have to swap it over to use the oxide variants. And then pull and push. Alright, do your thing. Uh-oh. Wait, no, it's working. There we go. Making highly enriched plutonium-241 oxide fuel. And it can only do, like, once it's done crafting, I think it'll push. There we go. And now we have EP241 oxide fuel. So this stuff, it's, I think that's per item. It's 286 millirads per tick. I guess we're shielded mostly from it. If I take a whole stack, 16 rads a tick. Yeah, no thanks. I don't know why I did that. I went through all this work to not touch the fuel, just to only... Stupid jetpack. Just to only go ahead and touch it immediately afterwards. Anyways, now we have to build the efficient reactor, or not the efficient reactor, the high cooling reactor, because this is a relatively high heat fuel. I ended up going with a 7x7x7 design that uses 38 active coolers. My limitation that I gave the designer was to use at most 38 active coolers, because that's the most I can support, the most I can keep fueled at a time. So 38 it was, and then it turned out to use exactly, where's my gadget here, 152 cells apparently, which is not half bad for only 38 coolers. So anyways, let's grab, whoopsies, I need a few more of those. 152. That'll do. I made another change. I forgot that there's no reason to turn off passive cryo coolers. Just because we're using active coolers doesn't mean that we can't use both active and passive coolers. So anyways, the building gadget cannot actually paste the active coolers, which is a little annoying, but how do I actually do the thing? That places all the cells and passive coolers, and then I just have to go back through and fill in the actives myself. So the way this is laid out is all the actives will be accessible from the outside. Let's just start from the bottom layer. From the bottom layer, there's one right here and one right here. Yeah. So we just, to use active coolers, you drop an active fluid cooler on layer 1 touching. Wait a second. That's an air. It's a second block from the edge. No, it's, whoopsies, right here. There we go. There's some air blocks in this reactor design, so it gets a little bit tricky to figure out where exactly you're putting stuff. But anyways, you just put the cooler right there, and then touching the cooler, you put a reactor buffer, I believe, or just a buffer, not a reactor buffer. And then you pipe your cryothium into here, it goes into the cooler. So likewise, cooler, active cooler there, buffer here, close it off. All right. Starting on the second layer, you have to keep having to punch holes here. This is where things get even more weird. So the cooler itself goes here, but obviously you can't pipe into that. So what you have to do is, that's an item conduit, get a fluid conduit to pipe into that. And I don't think you can extract from coolers, but you can extract from another buffer that you place here. But I don't, how do I place a buffer and get it to extract? Like, oh boy. Placing these is going to be such a pain in the butt. All right. Place the buffer there. Set you. I guess we'll just use the green channel this time. I'll break my rules so I have less configuring to do. And because everything's on the same fluid in here anyways. So yeah, this will, but fluids that go into this buffer get sent into that cooler. Nice. Thankfully, those are the only ones that are internal to the reactor. Everything else is, oopsies, on the external side so that it can directly touch a cooler. So anyways, I'm gonna, I wish the cells weren't so transparent. I have a little hard time telling like where actually a cell is and where isn't. But maybe I'm just whining. I will post the link, I guess, to at least a picture of the reactor I'm designing here in the comments if I remember, just in case you want to copy my awful design, although I highly doubt that it's the most efficient one, but it'll probably mostly function. Here, I think I got all the coolers in the right place. I have no leftover coolers, which is good. I do have leftover cells. I think that's just because I withdrew extras though. So I had to put the casings on. Oh, did I not make enough casings? Well, make me another 500, please. That shouldn't take too long. And horizontal walls or vertical walls. Do I have enough? Ah. Hopefully this will, I guess the red means I don't have enough. All right, let's let that crafting finish real quick. And this should do it. So with that, our reactor is structurally complete. It needs a controller, and we have to pipe the cryothium into it. So each of these buffers just needs to have cryothium pumped into it. For that, I'll use fluid lasers, I imagine. It's the easiest way to connect a whole bunch of individual points with the minimum amount of configuration. So go in there. Another upside of lasers, you get to draw these pretty pictures with them. We already have a melter set up to make cryothium, so if I connect this fluid interface, it should fill up with gelid cryothium. Put a laser here, connect you to you, and use yield compass as a set you to extract. Because still, compass is a totally reasonable tool for that. Then what I have here is a fluid level emitter monitoring gelid cryothium set to turn on when we have more than 20 buckets of gelid cryothium. So what that's saying is if we have, basically if our gelid cryothium amount is low, it'll turn off. So right now, because it's filling all of these internal buffers, like these, both the buffer itself has, well, a buffer, and the cooling active coolant cell inside also has a buffer. So because it's filling those up, our cryothium amount is low, which means that that reactor is not, well, it means that the level emitter is not on. And then to control the signal from the level emitter to the fusion controller, I just have a block that I can push in the, you know, take it out of the way so that the redstone signal doesn't reach, and that'll cause it to basically, this is my manual override, and this is my safety switch. This turns it off when our cryothium runs out or runs low, and this turns it off when I want to turn it off. So I'm going to leave it an off for now, actually. Give it a little bit of time for our cryothium to fill up all of these buffers. Each one has a pretty meaningful internal buffer, so it's going to take it a little while to fill these up. In fact, we might have to... It might be worthwhile to speed up our cryothium melting Right now we're melting cryothium just like with a melter. This is kind of the obvious way to make cryothium, but I saw that if we actually use a fluid extractor, it's 100, oh, it's 120 seconds, not 120 ticks. Never mind. I was about to say, I think this is actually faster than, this is what, 800 ticks, which is divided by 20, it's 40 seconds. Actually, no, that's 40 seconds per versus 120 seconds for, and this is 8 for 8. So this is technically faster. Or I suppose the other way to do it is just to add a bunch of melters. All right, let's just use a lot of melters. Even with 4 melters filling these up, it'll take some time because there's like 38, I guess there's 38 buffers, 1 buffer per active cooler. I went with 38 because that's a number of active coolers 1 melter can support, but now that I have 4 melters, we could have done more. Whatever, I'm not going to redesign everything now. This thing now has its fuel, so that's provided via an ME interface. A full stack of this fuel, by the way, 18 rads per tick. No, thank you. I guess instead of, while this is like the, you know, the automated safe way, I can just power it with a lever, and that causes it to turn on, making actually this one reactor makes more energy than my entire nuclear fusion setup. It's kind of funny. I may have underestimated the amount of power we get out of fission, but whatever. The thing about fission is it does devour fuel. So anyways, as this goes through that, it turns the one fuel into the spent fuel, which means we can now begin the process of encoding the next step. So come over here, add depleted, and we can touch the, oh, not that one. We can touch that one. That's fine. Add that there. May as well make it a full stack. Ah, dang it. And then when we reprocess that, we get curium 247 and 246, and I think some 245 as well, but I don't need the 245. 247 and 246 make our next step, which is curium 247, highly enriched 247. So I think we've seen this process enough times, right? I'm just gonna set up another crafter to make this fuel, and yada yada yada. As I add more reactors to this chunk, I'm intentionally putting all my reactors in the same chunk so I can just put all my radiation scrubbers in the same chunk as well. And it's actually with I just like scatter a bunch of scrubbers up there, right? We're down to nanorads per tick. Well, at least while this reactor, I don't think it's running right now. I think we've gone through all its fuel. No, it is running. Some of the higher tier fuels though are extremely radioactive. So I think we might eventually reach a point where scrubbers can't keep up. But for now, we're seemingly okay. I mean, 8 nanorads a tick is basically 0, right? Nice. Got our nuclear processing up to the point of running highly enriched Einsteinium 252. Anything higher than that, I just don't have enough output to like start configuring crafters and that jazz yet. So one advantage of setting up my my nuclear processing like this is that I can just open this terminal and see all of my isotopes. And what this tells me actually is that I have a lot of neptunium that I'm just not using for anything. So instead of not using it, why don't we use it? This ratio of 236 to 337 is pretty good for lowly enriched, right? Lowly enriched is 1 to 9. We have what, like 1 to 4. So basically we'll use all of our 247 to have some leftover 236. It's tough to get perfect ratios. This is as reasonably close to perfect as we'll get. So anyways, we may as well make and run that fuel, and because it's a lowly enriched fuel, we can run it in one of our cryolattice reactors. So yeah, I don't know if what we get out of lowly enriched neptunium is actually like terribly useful, but whatever it is, it's more useful than sitting here doing nothing. On second thought, the by using highly enriched fuels, the byproducts we get from reprocessing this are actually useful, whereas the byproducts from lowly enriched are less useful. So we end up wasting a bunch of neptunium, I think 237 it is. Yeah, a lot of this excess stuff will end up just sitting here doing nothing. But then we get useful like plutonium isotopes and uranium isotopes out of it. So I think it's better to do this. Anyways, the XS237, is there really anything we can do with it? We can turn it into uranium-233, but I think we're already swimming in that. So I think it just sits here doing nothing. All right, doing nothing it is. For this Neptunium fuel, it's a little bit too hot to run in standard cryo lattice. So it's 1024, I forget the number, 236 oxide. 270 heat, right? The highest we can safely run in cryo lattice, I think, is like 160, maybe 161. Even the non-oxide version's a little hot. So instead of running it in this 7x7 actively cooled reactor that is way overkill for it, right? Because this handles 1600 heat. This is only 270. I'm going to build a slightly modified cryo lattice that can handle 270 heat. So I specifically asked the reactor planner to make me a reactor with a bunch of, just these two blocks. So it's fully passively cooled, and this is what it spat out for me. It's yeah, a bunch of cryothium coolers and cells, but it's arranged in a slightly different pattern than the purely alternating grid, so that there's more coolers and slightly less cells. Well, that should do it. And let's just put the walls on it now, and then we should be good to go. And it's just as we drew it up. Almost no cooling wasted, but 100% passive, so I could just force it on and it's incapable of overheating. Boatload of energy, and this will use up our many hundreds of Neptunium that otherwise would have just sat around doing nothing. Excellent. All set. So over the course of one day, we've gone from one nuclear reactor, or one fission reactor, up to 5 fission reactors, and various nuclear fuels being processed into good stuff here. So I'm just going to leave this running between now and the next episode. Hopefully when we come back, we'll have a bunch of these heavier isotopes. I think Einsteinium-254 is the next step, but there's, 1, 2, 3 steps left before Fermium-257, which is the last one, because it yields Neutronium. All right. But yeah, it'll be some time, I think, before we get there. And our current Neutronium production rate, oh boy. If I had to estimate, I would say it's somewhere around the order of a nugget per hour, but we're definitely going to have to scale that up if we're ever going to do things that actually use a reasonable amount of it. I don't know. That's just my estimate, though. We'll see where it ends up actually being once we have the system fully set up and built. And we have like our, we'll have to scale up our ore or our mining in order to make sure that we can keep running like our TBU and uranium-235 reactors at 100% uptime. But yeah, lots more future Nuclearcraft stuff to come, I guess is my point here. Anyways, I hope you guys enjoyed this video, and I hope to see you in the next one. Take care. Bye-bye.